Alright, welcome back to this video. So in this video we'll be talking about errors and exceptions and how to handle errors in our Python code. So we must have gone through we must have experienced different errors in our codes. I mean, like it might be as little as trying to print hello and then we forgot the quote there, so we get a syntax error here, and it gives us a detail of the error itself. Sometimes you might even, it is still a syntax error, but it is a different detail we get for this kind of error. You can say incomplete input, but it is still syntax error. So we get lots of errors in our code, and there are a whole lot of them. If I show you what they are now, I mean, hold on a minute. So if you see all of the errors that we can possibly get from our code, like you can see the base exception, arithmetic error, zero division error. So we will actually touch like 3 or 4 of these errors, because I mean, there are a lot, and some are not directly in our typing of code, but there are some that are gotten from maybe a user passes in an input, or you try some additional multiplication. Like this syntax error now, the Python is unable to compile the code, so that is when we get the syntax error. But there are some errors, like when you ask for user input and you try to do some division. Let's say, for example, if you try to do 1 over 0 now, so we get a zero division error. So when we look at the detail of this error, so I don't need to define what the error is, but we can see that this error raises this code raises an error or an exception, and then we get a traceback. So when Python encounters an error, and wherever you are in your code, if you don't undo the error, I don't think you must have known how to handle error yet. So if you don't handle the error, the program will just, it will halt, and then it will show us this traceback that I pointed to here, and then we get the error message, the line number is line 1, and all of that, and then what led to the error. So to handle all these errors explicitly, we can actually raise our own error first. Let me give, for example, if you use the raise keyword now, this raise keyword is the one that we can use to raise error. So there is index error. If you look at this thing here, there is index error. So if we raise index error, we can have that. So you can see that we can raise error with this we can raise error with the raise keyword, and we can even pass in an error message for the error. We can say index error occurred, something like this now. So you can see that we were able to raise our own error and pass in the the message. So normally, if you don't pass in your message and Python generates an error, so if you don't pass in a message, normally Python will give you the error and then give you the message for the error. But what if there was a way that we can actually control the error? We can handle it and say, okay, if it is index error, this should happen, this should not happen. So that is where the try and except clause, let me put it this way, except clause, that is where they come in. So what this means is that in the try clause, if you want to write a particular code, or a code that could probably get an error, like if you want input of a user in form of an integer, right? So that it's possible for the user to put in a string and put like spam, and if you put that normally in your code, it will crash. And then this try is where you, inside the try block, you can see you indent it, you put in the code there. Then the except is where you now use to say, okay, except any error occurs, do this. So in our own situation, let's just say print error, right? So when we try this now, so let's say we write spam, you can see that it brings in error. if with that we just did this without using the exception handler, without handling the error, and we just do this and we write spam, you can see that the code actually crashes and it says trace back this invalid literal for ints with base spam. So yeah, this is how you catch an error and handle it. So let me give more detail about handling error. So in this example we did there, this except that we put here is a general clause without passing anything next to the except. If you just say try this and except print error, it means that if it brings in index error, if it brings in a value error, it brings in zero division error, it will just print this error. Now, what if we are able to customize it and we are able to manually state, okay, if it brings in this error, do this. So for example now, if we want to say that, okay, for it to handle a value error explicitly, this is what should happen. We say try that function, except a value error, print this. So print value error occurred. So when we do this now and we write spam now, it is still the same thing that happened there, but yeah, we're able to specify the type of error to happen. So when we handle our error like this and we print, okay, value error occurred, normally if it was Python that was to do this, it will say value error occurred and it will give us a detail of the error that occurred, but the disadvantage is that it will also crash the code. So if we want to also give the user the detail of the error that happened, we can also write except value error, like this. Then we now say as e or as anything you want. Then we'll now print the value error, or we can just say print error. Then we pass the error that happened there. So in this situation, when we do this and we write spam, you see it says error, our own part, and then it prints this e, which is invalid literal for int with base 10. So this way we can actually show the user the type of error, and then we can also do this. Also, we can, after catching the error, we can as well continue our code and say print continued like this. So if you write spam and it catches the error, it still prints continue. But if it was something like this now, when Python handles the code normally, if we print continue here, you can see when we write spam now, you see that the continue clause did not happen because the code has actually crashed here. So we've learned now that we can catch the error, the specific error that could be gotten here, and we can even get the instance of the error. This e means the instance of the error. You can decide to use I, you can decide to use anything, and we can combine in our own print statements, which we are manually doing. We can now combine it with something else. So what if there is a case like this now? Let's assume that we have our code like this, but instead of I don't know the probably code that we might want to write. Let's assume it is an index error that is gotten. Let me do it this way. Raise index error is the same thing as saying if the user passes in an input that gives an index error, do this. So I just want to, this is just a shorthand to write our code. So the raise will just raise the error itself. So let me just say raise index error occurred here. Okay, so what if the error that was passed in did not match the error we were trying to handle? Let's see what happens here. So you can see that the program actually crashes like this, just like the previous place. We still get the detail of the error, but our value error did not catch this index error. So it is actually very possible for us to catch as many errors as possible. Like after saying except value error as e, you can also say except index. You can also say except index error as e, and then we catch the error. So we can see it here now that it say it catches the error now and we get continued printed out. That means that we're able to catch the error. So even if we continue going and going, we can still say except zero division error as this. The probable errors you think that particular code you pass there can be raised from, you just put it like this. But at the same time, this passing it like this value error might be able to help you and say, okay, value errors is caused when you pass like a string for instead of an integer. So you can easily say print error. Let's assume you are not using exception now. You can easily say print error. Don't pass in a string. Don't pass in a string, or only passing an integer. The index error will say pass in a number that belongs to the given index. I'm just giving an example here. So what if we don't need to be stressing ourselves to be writing this and this and this. We just want Python, just like we did here for Python to, where were we? We just want to just show them the error, just like Python should generate the instance of the error, and we should just pass in this error word or something like that. But for us to just catch any error that comes in, that way we can actually combine these two errors in one line by saying, let me copy again. No, let me copy this one here. So we can actually combine the two lines together and say except value error, and just put a comma in between them and say index error. So this way we are catching both errors together, and we'll say print error as this. Now if I print this, we get another error, a syntax error, because of if you are passing in two errors or more at the same time, you have to put in parentheses between them. So instead of this now, what we are meant to do is we are just meant to put this like this, and we'll put this. So if an index error is raised, what did I do? Oh, I did not put as E here. So you can join both of them together and put as E. And when we do this, so you can see index error occurred here. So if it is a value error that also occurs here, and then so it also catches it. So we can easily combine these two if we don't want to be specifying, okay, don't pass in a string, don't pass in a number. We just say, okay, an error occurred, we cut the error, and then Python should by itself say the instance of the error that happened there. So we can just combine both of them together in this except clause. That is another way of handling error. Now let's assume again that, okay, now here these two places again, we are checking the possible errors. There are so many errors such that you might not even know the error that will be generated from your code. And if you use this except, where do we use except? If you use except only, you will not be able to catch the error. And I don't think it would be advisable for you to put everything in parentheses, all the possible errors. So the way we can actually catch all possible errors anyhow, in every way, wrap all them together inside this bracket, is by calling exception this time. So when we want to call, instead of writing except value error, index error in the parentheses like this, so we just say except exception as E. So this means that whatever exception happens, whatever exception whatsoever, print this, and then print the detail of the exception. So this is the one I actually use. This is the one I use the most, except exception. I can't have the time to be writing this for this, this for that. So if we have a value error that occurs, it says value error occurred here. If you have index error, if you have zero division error, which is dividing by 0, we get I meant to change this, but it doesn't actually matter. So what we will be able to do now is that we will be able to run a code that raises an error, we'll be able to catch whatever type of error is coming in. We also catch the instance of it. We print the error, we print the instance. So we can decide to remove this E here. We can decide to remove the error here and only print the instance. We can decide to do anything else in this except block. So that is how to generally catch errors. If you are actually talking about working with user input, right, what I do mostly is that, let's assume in this kind of situation now, we want to work with the user input. You know, in when we did spam there, after catching the spam error, we continue with the other parts of the code, but the mission has not been completed. I mean, we wanted the user to pass in an input. It's not that we just left it like that. So the way we can actually do it is that we catch the error, give the user the error, and give the user to an opportunity to pass in another detail to replace the initial one, is by wrapping it in a while loop. So yeah, we can wrap the whole try except block. We can wrap them in a while loop. We say while true, we put our column there so that we won't get an error. Then we do this. So what we have to note here is that this is the while loop, infinite loop. If we don't set a break anywhere, it will just crash your program anyways. That is another problem. So what we can do is, let's assume we are working with input now. Let's say sum is equal to, or let's say, let me use this. So let's say we are working with division. First is equal to int input, right? And then the second is equal to int input. So let me say, yeah, we are printing a result, and so what we have actually done here is that we've written lots of code. As I said, your code inside your try block can be long, but it is actually preferable to just, what should be inside your try except block should be parts that can raise an error. Actually, not that we are writing normal code that it is just syntax error, which Python will actually tell you that you are already doing something wrong. So in this situation now, we want to handle the error such that, you know, the user might pass in spam as the integer, or might pass in 0 as the second, which is zero division error, or this one which is value error, and something like that. So for us to be able to let the user pass in the input again if it gets error, that's why we put in the while loop, while true there. So when we run this now let's generate error now. When we say spam as the first, you see instantly it did not even let us bring in the second, because the try block immediately it catches the error. It doesn't even run any other thing. It just raises an exception immediately. So that is what happened here. So here now, after raising the error, or maybe I should, so that you'll be able to know that it is first that is coming again. 1. Let me just put 1 there, and let me put 2 there. Okay, so the first now is when we write spam here, we get the error immediately, and we are told to rewrite spam again. So what happened is that after this try block executed this first line and it caught the error, it jumped to this next line, which is the exception. Let me space this now. So it jumps to the next line, which is the exception. It prints out the error that we handled, and then it repeats the loop again. Oh, I forgot to put break here. If that we had passed in the 2, we'll just keep on repeating this line again and again. Let me do that again now. So let's now pass in a correct value for the first now, and then we pass in 0 for 2. So once we pass in 0, it says error again, division by 0, and then it stops it. Now the only time this break that we put here will pass is when this first line and this second line is not only when this first line, when the whole code in this block goes on. Like the zero division error, we have taken in the first, taken in the second. It is during the division that this zero division error was raised, right? So it took into consideration all the lines of code inside the try block before it's undergoed before it's tried to break the statement. So when we now try normal division and we say 6 divided by 3, so you can see we get our result 3.2.0, which is the print statement here. So that is how I undo user input using the try except block. So using the while loop to undo user input combined with the try except block. Aside from the try and except, there is another one we can actually make use of, which is the try and finally. Where is it? So which is the try and finally block. How will I put it that? So the finally clause will always be printed, or it will always run even if an exception is raised or not. So it is like a clean up that, okay, whether you raise the exception, whether you undo the error, whether it doesn't undo the error, this line must run. So the exception, even if it is not handled by the except clause, what will happen is that the error will be raised again. Now let's assume we got a value error here. Let's assume we got a value error here. No need to put this there. And then finally we print final. So what happens here is that you can see that what the code does is that it went through try block, it got an error, it looked for the exception, it didn't find. Once it met finally, it must first answer finally before it raises that error. That's why the final is at the top, not at the bottom of the error code, and then it prints out the error and normally code will crash. So we can combine try with the finally block, and we can also put in the except here. So we can catch the error. So we can say except exception, whatever is coming, as print So what happens now is that you can see that once you catch the error, the final block will still happen. Now you might be wondering that what is the difference between the finally and us just printing this result here. Now you won't actually see it in this scenario here. You won't see it here. Okay, the first difference obviously is that if you don't print this, if you print outside of this error here, now if you say print hello here, it catches the final but it doesn't print hello. But in this situation it catches the final. Sorry, I mixed it up now. I wanted to say that here, anytime an error is raised, this print statement wouldn't come out. But for the finally, whether the error is raised or the error is not raised, the print statement will come out. The finally clause, it has its own like rules. It has its own guidelines with it, because it is a little bit special, a bit different from others. Like, let's assume we wrap our code in a while loop, while true, then we write our code here. So when I tap this, so what happens here is that if we pass in something that is good here, for example, we say print good, right, and then we break it here, we have exited the loop at this print statement, at this break here. So you might think normally exception would be raised, nothing will happen here. You might think that finally won't be raised or you might think that finally will be raised. And let's now print, let me print something else outside here. So you can see that even though we broke even though we stopped the code at this point here and the exception is not raised, the finally is printed before the done. You can decide to at the same time, okay, I think that is where the finally will come in very handy if you want to break your code anytime in a loop. So you might forget to put your break here. Just know that finally break the loop in case you are working with a loop. The break will be very good in finally. So let's see, if I put the break before I print finally, okay, nothing will happen because normally Python will not allow that. So yeah, in this situation now, if we do this, we get exactly the same result. Good gets executed first, then the finally clause, and then the done printed out outside the loop. What if an error is actually raised here? This way you will see, let me now show you this now. Another clause, another guideline for the finally is that if we want, even if an error is raised, we want to ignore the error, you know, like here, and we don't catch the error. Let's assume we don't catch the error now, and an error is raised like a value error. So if we have a value error raised here, you know, normally when we did example above, I don't want to be going up again. When we did the example above, this final got printed, then the error got raised. But because of this break statement in this finally, when we run this code now, we see that finally got printed, and then the code just continue running normally. Because remember when I was showing how it worked is that when the error happened, the try looked for an except to see if the error was raised was handled. When it saw that the error was not handled, it continued by saying, okay, finally, is there anything I have to do? You know, finally. Then the finally was printed. Then after the finally is printed, it is meant to raise the error. But because of we've actually printed break here, it will not happen. It is meant to happen right after finally. But we've already broken the code already at finally. So the error is not raised. Finally also works in functions also. Let's assume we have a function now, and then we have a function that divide, we have x and y, right? And then we want to try, maybe the user passes in 0 as y now. We say try x over y, right? Return x over y, return x over y, right? Then we don't catch any error, or even if we catch error, let's just say finally print finally. So when we do this, let me now print something else outside here. No, this one is not actually needed. It's a function we're working with. So when we do this, and when we say divide 2 and 0, I'm meant to get a 0 division error, and the finally got printed normally. So what I'm trying to point out here is not even this point here. It's not here. Let me now put this and say, if we return something in this finally, instead of printing now, if we return this, in this line here, we did not return. What was meant to be returned is this x over y, but because of an error got occurred, it only printed finally. Now if we return finally here and an error occurs, what will happen? Let me just show you instead of saying it. You can see that finally actually got printed, not the return statement. If you remember again that not in functions, once the code reaches a return statement, it stops already. Just like a while loop, once it sees break, it doesn't count anything under the break. So when an error was raised here, it checked the finally statement, and because the finally is returning something, it stopped immediately. So yeah, we can actually use this for No, I don't think that's well. I wanted to say we can use it for a default value, but that's going to complicate things a little bit more. Even let me also say that even if your error doesn't, even if your code doesn't give an error, once you can put a return statement here. So let's say divide is meant to say x, return x over y, and then here we say return finally, and then x over y does not give any error, and we say divide like 6 and 2. We will expect our answer to be 3, but our answer is finally. That is the complicated part about finally. It is the last man in the line. It always gets run whether you put the break statement before it, you put it after it. I'm sorry, like if you put it in the try clause or you put it in this place, the finally will run. If you put return in the try, if you put return here, it will still work. So finally is like the universal, whether it is the stubborn part of the code, whether exception runs, whether error occurs, whether error does not occur, finally will always be passed. That is one of the what will I say, the guideline of using finally. So you can use try finally, you can use try except, you can combine try except and finally together depending on how well you want to handle your errors. Now, apart from try except finally, there's only one that is remaining, and that is the one I actually like using. I like combining very well. I mostly don't use the finally part of it because I've already seen so many reasons why. It is only if you actually have a plan, a process, okay, this is what should happen, that finally should be done with. But most of the time, it is this third part I actually use. We have the try. Let's say we raise an error. Raise index error. Then we have the except, which will catch the error. Except exception as E or something like that. It will catch the error. And now the next part after the except, right under the except, before finally, is the else clause. Now the else clause condition is very simple. It is like the good side of finally, not the bad side of finally. The else clause only gets executed if no error is raised. So if I say else print, this is what this one means, no error. So here we have an error raised. So when we do this, it only says the error and then it stops. It doesn't print this line. But if no error is raised, I want to make the examples many here. So if no error is raised, I will just say print try block. So you can see that try block happens, no error happens. If finally is here, finally will happen whether an error occurs or not. So I don't even want to talk about finally again for now. But you can see that if no error is raised, the else statement will happen. Now, I actually really like using this else statement. I use it every single time to handle user input. That is, if I want to, like, where was I working with input? Okay, this is the line. Let me just copy this whole code here. Now, the reason I like using the else statements here is I mostly use it inside a loop, and I use it to validate a user's input. So when we say else, let me say print else. Okay, so let me remove this result from here, and then, as I said, let me also remove this from here, and let me bring this to the else statement here. Now let me explain what I'm trying to do. I'm trying to show you that this, we printed a break here. Let's see what will happen when we do this. And we say the first is 6, the second is 2, what happened? Oh, the break already exited the loop here. The break exited the loop. If there was no loop here, damn, I don't want. This repetition is getting so much time. So when we do this here, you see that break. Let's assume we are not in a loop now. So when I enter 6, 6, and I enter 2, you can see the else statement actually runs. The reason it did not work here is because when you break something, when you break inside a while loop, it breaks unless you are working with the finally, which is the stubborn child, and it will actually run itself before the break statement. But if you are working with else simply means, as I've said, that if it is successful, do the else. So let's work with this else and let's carry the break as I used to do. Let me say this is not marked down. Okay, so now let's bring the break to the else statement. Okay, so what I'm trying to do here is to show you how we are going to validate, but first let me just result. So what is going to happen here is when we bring in the first, we bring in the second, if no error occurs, that means the except is not handling any error, it goes to the else statement and it prints the result. Now let me show you this. It did not print result. Okay, so you can see the result is printed out. Now I've said now so many times, what I don't want to skip a step, that's why. So the main part I want to show you why else is very, very useful is when you want to validate that user input. Let's take for example with this now. Let's say we don't want the first to be greater than the second, or how will I put it? We don't want the first to be greater than the second before we get the result, or we don't want the second to be greater than the first. So what we can do here, we'll say if second is greater than first, right? If first, second is greater than first, we can now say print second should so we'll use else here. So we can actually wrap in else inside the else block. You can see here. So what I did here is that I want to validate the input they brought in. I don't want the second to be greater than the first. You know, we're in a loop, right? Which means that if a break statement doesn't undergo here, it starts the loop again. So if second is greater than first, it will tell the user that, oh, second should be less than or equal to first. And then what? It restarts the loop because no break statement here. Else, it will now give us result is equal to first over second, print result, and you break. So here we validated the user input before exiting this loop. Because if we do this validation outside the loop, there's no way for the user to be able to re-enter his input again. So let me show you. Let's run this code now. So let's say the first is 2 and the second is 6. So it says second should be less than or equal to first, and it comes back to this line 1. You can see 1 here. It comes back to that line and tells us to try again. So now when we now bring in 6 as the first, 3 as the second, then it prints out 2.0 and it breaks. That is how the else statement works, and that is what I actually use it for most of the time, to validate the input. To, let's assume now we are working on a code and then we want to use this user input to get a value from a dictionary, and then if the value is not in that dictionary, we tell the user that, oh, sorry, this value is unavailable or something like that, and then we tell the user to pick, or you can use it when you are doing the number guessing game or something like that. Well, it is, if you are practical about it, you'll be able to know why else statement is very, very useful. I don't know of that of the finally, but this else statement comes in very handy. But I think that is the basic part of this else statement, which is if the try block doesn't undergo any error, else is going to happen. So if there was a finally here, what we just have to do is just put it by this side and say finally print validated. Say print validated output exiting loop. You can see even if the break is still in the else clause, the finally will still be printed. But if I'm to use a finally, I mostly use the break in the finally side. No, because if you use the break in the finally side, the error wants to be generated if another kind of error happens. I mostly use the break in the else side, but if I'm using try except finally, no else there, I mostly use my break in the finally side, and I undo the error the way I want to. But I don't mostly use it in a function. Inside a function, I don't use it to return, maybe unless I want to print something and say this happened or that happened. So that is basically what handling exceptions is actually about. It is not as complex as one would think. It is just is lightweight tool to help you, handle user input. Basically, honestly, it is mostly user input, or maybe in the process of your code, if something happens, to show the user or the person consuming your code the kind of error that happens. So you can see there are so many errors. There's even import error. I didn't mention that. I mean, if we try to say import blah 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 and then we run this, we get module not found error. And module not found error is a sub component or it is a class of import error. Let's say from random, random module import from random import something that doesn't exist. When we do this, we get the import error. So you can see import error is raised. So we can actually work with that also. Let me show you where that should be. Import error. Okay, you can see it here. Module not found error is inside import error. Arithmetic error, floating point error doesn't exist. I don't know why it is still here. Is it overflow error that doesn't exist? One of these two doesn't exist. But we've seen assertion error. That one is still another way of validating. It's like another way of adding exception, but it is different from what I was trying to explain in this video. So you can actually go to the Python documentation to get a list of all the built-in exceptions and errors, and that's just what I want to talk about in this video. I hope this video was able to help you understand more about handling errors and exception. I'll see you in the next one. The next video is where we'll be doing the Roman numeral calculator. I intentionally brought this try except before the Roman numeral because we are going to validate whatever a user brings in before converting it. That is why I brought in the try except error validation exception handling before the Roman numeral converter. So if you want to watch that video, you see it in the link will be in the description when it is uploaded. And maybe I'll see you in the next one.